So we've just added a further short video to this list. So we've got 5 in this series. And just to take the ray diagrams idea a bit further, we've got this 5th one now. So here we go. So here's our setup again, same as before. We'll turn the lights down, you'll see the little light ray. I've already marked the first one and the position of the mirror. We'll move the mirror out of the way and then we'll put in the final reflected light ray, then measure the angle. So let's have a look. Turn the light down. Adjust your eyes. Yeah, we can just see that. So what I'll do is, there's our little mirror there, move it out of the way, put the light back on. There's the final reflected beam, so that's our light ray, which is the incident. Sometimes just the letter I is used for that. And then there's the point at which it struck the mirror and reflected. Here's the reflected ray here. So drawn through that point and the point near the mirror. That was the position of the mirror, there's the back of the mirror. Now when it comes to measuring the angle, so that's the reflected light ray, measuring the angle, what we could do is use our protractor. Now turn the paper around to make life easy for yourself here so you can see the numbers more easily. And we need to accurately position the cross point, the crosshairs, the centre of the protractor right on the position where the light beam reflected from the mirror. So it's the actual point of contact with the mirror. So that's got to go in place. We also need the zero line of the protractor along the mirror itself. So it just takes some time getting this in exactly the right place so that you can measure it very, very accurately. Yeah, that's looking like it. Looks like it to me. It's just tiny bit there, tiny bit there. So let's have a look. This is the line of the mirror. This is the zero line, is the line of the mirror. That's the light ray that was incident. And we'll look, in this particular case, I've set this one up 40 degrees. So that's 40 degrees between the zero and the light ray itself. And then if we check the other one, that's the 0, 10, 20, 30, 40 degrees. So it looks like the angle that the light rays bounced on and the angle the light rays reflected off are exactly the same. Now there are conventions in science, and the idea is that if we all make the same measurement, then using the same method, then we can compare our results. And one thing that really we should consider here is the sort of official, the proper way to do it. Well, I've measured the angle between the mirror and the light ray incident and the mirror light ray reflected. So that angle and that angle. Whereas the convention is to measure what's called the normal, or from the normal. And the normal just means a right angle drawn from the point of contact where the light beam did its reflecting, and that right angle between this line, which is called the normal line, and that's the right angle there. So really we're measuring, there's a right angle. We're not measuring this angle here and this angle here. We're measuring this angle here and this angle here. So it's simply a convention that we draw this special line called a normal. How do you draw the normal? Put the cross point on the point of contact there where the light beam reflected on and off, and then use your 0, 90 degrees, make a mark, draw the line, and that creates what we call our normal line. And then the measurements you make in terms of angle are actually not these ones, they're these ones, not that one. Well, a little bit of mathematics. This was 40 degrees, and if 90 degrees was the total, am I right there, was it 40? Yes, 40. Then this must be 50, and if that was 40 degrees, which is, that's how we recorded it, that must be 50 as well. 40 and 50 is 90. So really we'll get this, we'll get a different numerical answer, a different number, but the same conclusion, because the incident ray and the reflected ray have exactly the same angle. with reference to the normal line. So really, this is the correct measurement. This is the correct measurement by the normal standards that scientists have, using this special line called a normal line, which is a right angle to the mirror and emanates from the point of contact of the light ray. So the diagrams can look a bit more complicated, but let's get rid of the bit we don't need. Don't need that. Don't need that. So that simplified it a little bit, hasn't it? So when we draw light ray diagrams in future, we need to draw that normal line, and the angle we measure is the angle between the normal and the incident ray, between the normal and the reflected ray. Now, in order to prove that we're going to get this relationship that the reflected angle onto and off the mirror, the incident and reflected, are the same, we've just got to repeat this, but not using the same angles. Try different angles. So I've tried 50 degrees there as the incident angle, and I've recorded 50 degrees as a reflected angle. Well, what if you were to try 30 degrees? What if you were to try 60 degrees? What if you were to try 21 degrees? What answer could you expect, and how are you going to prove it? Okay, so that allows you to take your investigation further.